finally dropped in there.
Don't drop your phone.
I won't. Angie, move your hand, don't do that.
The chemical element that produces that green color is called copper. Now, you probably heard of copper before. You're probably familiar with it as a metal. Like, kind of, you know what pennies are made out of, right? Electrical wiring pipes. It's really common, sturdy stuff. Metals like spray bottle. If I spray that into the air, that fuel's going to take up a lot more space. And if we put it near a flame, it makes a big green fireball. Alright, so when I spray this, I'm putting out a similar amount of fuel up to here. Up here is what I have. Here is our strontium, that bright red you can see is on a lot brighter. All that fuel is giving off its energy in a big, quick burst. So every little bit of that is kind of in a mist. It's a little bubble surrounded by the oxygen in the air, so it can all burn up a lot faster. Here is our strontium, that bright red you can see is on a lot brighter. All that fuel is giving off its energy in a big, quick burst. So every little bit of that is kind of in a mist. It's a little bubble surrounded by the oxygen in the air, so it can all burn up a lot faster. Ooh, there we go. And see a few sparks of magnesium pop out of there. Ah. There we go. So you can see that even in some really unexpected places, where there's not oxygen in the kind of conventional way we think of it, even we think we might not have the right ingredients, there can be some creative situations where you can get a fire with some unexpected materials. A metal like magnesium, carbon dioxide, all put together to give us this nice glow layer. We'll let that keep burning. Developed by the experts at the St. Louis Science Center Space Program. We call it a whoosh bottle. Ooh, ah. Very cool, right? Thank you. Now the way it works is basically there's a big hollow empty space on the inside of that. We can put all our ingredients, we can add them through this opening in the top. So we put all our stuff in here, have that react inside the bottle, contain the explosion within, you know, and not on me. So what do we have in here right now? Air, which contains oxygen, right? And I don't mean that to be a trick question, that's an important thing to be aware of, right? We have to think about our oxygen when we're talking about a fire. So, we know we have that ready to go in there, we have a certain amount inside that bottle that's going to help us out. So I'm going to add to it a little bit of our fuel, that ethanol mixture. We're going to put a little bit into here.
Is it going to be loud?
Just like so.
Is it going to be loud?
Now we don't have a whole lot. You see, this bottle is bigger than this bottle. That's a fun science fact you can take with you today. There's not a whole lot of this stuff in here compared to the size. But what I'm going to do is I'm going to put just a little bit in there. You don't actually need that much. I'm going to do something really cool. Check this out. We're going to use a special patent pending technique known as shaking it up. And as I do this, what's happening is that liquid fuel is going to kind of start to evaporate. It's going to mix with the air around it. Right, so if we have this flammable vapor, as we've seen before, that's going to make a big difference. We spread it out, the oxygen around it. If you've ever been to a gas station, you know that gasoline smell? Yeah, what you're smelling there, basically the fuels, the fumes and vapors coming off of that gasoline, off of that same liquid fuel. This is the same idea, just with alcohol instead of gasoline. I'm going to move my dry ice out of the way.
No.
So you put our bottle behind our screen.
Oh yeah, it's going to be loud. It's going to be like boom. Like a boom.
So the last thing we're going to do once we have that ready, we'll give it a few more good shakes. Alright, and then we're going to add our ignition source. I'm just going to use a slider for that. That does a pretty good job. When I do this, it's going to make a little bit of noise. It might be loud. It's usually not too bad, but I'm going to count it down so you know when it's coming. All right, ready? Here we go. In 3, 2, 1. There you have it. That's why it's called a little pop.
The cranes.
Okay.
Stop it!
She's trying to help because it's not, like the legs are a little bit further back. You can put this at her. Okay, there you go.
Is it ready?
I think so.
Not yet, not yet, not yet. Are you recording?
Yeah, I am. Oh, we had some more legs we could have used. We could put those legs underneath to make it more stable. Maybe the support might be better for the bottom.
How about the middle?
Yeah. Oh yeah, the middle too. That's good.
Unstable.
Oh. Okay, hit the other green button.
No. Andrew!
Oh, did you do that on accident? It's fine, Adriel. He's gonna fix it.
So it's basically an earthquake.
It is.
So the bottom is going to... Are you recording?
I am. Okay, that's unstable.
Touch the building.
The green one? Did you do it? Oh, that one. That one. That one didn't make it. I'm not the only one that fell.
Don't touch it. Oh no, this one's gonna fall.
Oh, the other ones made it though, because they have the beams in the middle.
But this one's going to survive. This one's gonna fall.
Oh yeah, that
No, this one's gonna fall because look, it's cricket.
Yeah.
Look.
they're both gonna fall. I didn't know that. I mean, they're doing pretty good for it to just be going this long.
Imagine. Oh, this one's about to fall.
I think it's over.
Andrew, don't click it that many times.
Yeah, those two made it. The beam in the middle helped, I guess.
No, don't.